Hello, how you doing? My name is Jamica Hartley.
Hi, how are you guys doing today? I'm McTier, and today, today guys, we'll be talking about current, resistors, and capacitors. I want to start off by giving you guys some definitions. Our first definition will be current. The current state is the rate at which the change is flowing. So ladies, and sometimes current is on your hair flat irons. You'll see it there. Our next definition is for resistors. A resistor stops or repeats the current. Our last definition will be for capacitors. A capacitor is mainly an object that controls and holds energy flow.
Okay, guys. So before we get to solving the problem, I'm gonna explain what a parallel, basically what a parallel is gonna be in a capacitor network. So say you have this capacitor network, and you have your voltage, your C1, your C2, your C3, and your C4. So as in the picture or the diagram, you can tell that C3 and C4 are going to be in the same network. So your equation to find both of them will have to be C3 times C4 divided by C3 plus C4. And in order to find the whole value of the capacitor network, is going to be C1 plus C2 times this right here, or plus this right here, plus C3, C4 divided by C3 plus C4. Okay, so what Grant was talking about, we're going to be talking about capacitors. So say we have this capacitor right here, and we're going to just call it our capacitor network. So for the voltage that's going to be flowing through the capacitor network, we're just going to set it as 11.5 volts. And for C1, we're going to set it as 3.03. Alright, and so for C2, we're going to set it as 1.87. And for C3, we'll set it as 10.5. And for C4, we'll set it as 7.92. Okay. So the main question that we'll be trying to find with this capacitor network is going to be what is the equivalent capacitance of the network. Okay, so in order to find the equivalent capacitance of this whole network, our first step will have to be to find C3 and C4, and that's only gonna be because they're in a parallel. So since they're in a parallel, we're gonna have to add them together. So step one. C3 is gonna equal C4, because like I said, they're gonna be in a parallel, so they're gonna be equal to each other. And that would be and so this is gonna be our equation to find C3 and C4. So step number 2 is going to be finding the actual total of the whole capacitor network. So that equation is going to be C total equals C1 plus C2 plus C3, C4 divided by C3. Alright, and so once you do all of that, we're going to plug in our numbers. You're going to get 3.03 plus 1.87 plus C3, C4, which is going to be 10.5 times 7.92 divided by 10.5 plus 7.92. And so after calculation, and you add C1 plus C2 plus the capacitor total of C3 equals C4, you're gonna get a total, you're gonna get a capacitor total of 9.415. And that is gonna be the total equivalent capacitance of this network. Okay, so again, my name is Jamica Hartley.
And I'm McTier, and today we learned about resistors, capacitors, and currents and how they apply to the real world and problem solving.
And we also learned how to calculate the equivalence of a capacitor in a network.
Thank you.